Hello guys, in this video we will discuss how to create and initialize NumPy arrays. First let us see the easiest method to create an array. It is done by using array function. We can pass a list, tuple or any array like object into the array method and that will be automatically converted into an ND array object. See the example here. Array is equals to np.array of 1 2 3 4 5. Here this 1 2 3 4 5 is a list and this ARR is a variable in which we are going to store the array elements. Generally, when we are accessing any function from an library like NumPy, we need to write NumPy dot and that function name. In most of the cases, we import NumPy as NP with alias name. So here I wrote NP dot array of 1 2 3 4 5. This also can be written as NP dot array of 1 2 3 4 5. This is a tuple. This can also be written like this. We saw how to create an array. Now let us see the different types of arrays. First one is zero dimensional array. Zero dimensional arrays. They are simply scalars. They contain only a single value. Array is equals to np dot array of 42. Another example is np dot array of 35. This is also an example of zero dimensional array. Next one is one dimensional array. An array that has zero dimensional arrays as its elements is called one dimensional array. It is simply a combination of zero dimensional arrays. See the example. ARR is equals to np dot array of 1 2 3 4 5. Here 1 itself is a zero dimensional array and 2 itself is a zero dimensional array. It is simply the combination of zero dimensional arrays. So it is a one dimensional array. Next one is two dimensional arrays. Array that has one dimensional arrays as its elements is called a two dimensional arrays. It is simply a combination of one dimensional arrays. See the example. ARR is equals to np dot array of 1 2 3, this is a list, and 4 5 6, this is a list. This is one dimensional array and this is also a one dimensional array. It is a combination of one dimensional array. So this is a two dimensional array. We need to enclose this in another braces. Next one is three dimensional arrays. An array that has two dimensional arrays as its elements is called a three dimensional array. Simply it is a combination of two dimensional arrays. In previous example we saw that 1 2 3 4 5 6, this is a two dimensional array and this part is also a two dimensional array and it's a combination of two dimensional array, so it is a three dimensional array and we need to enclose this in another braces. This is about types of arrays. Now let us see some other methods to create an array. First one is by using zeros function. It returns a new array of given shape and data type but with zeros. It generates a new array which contains zeros and the size is given by us. I will show you the syntax of this function. NumPy dot zeros of shape comma d type is equals to float. Here shape is the size, I mean the dimension of the array, and data type is the type of data which you want to store in that array. Defaultly the data type is float. To understand this much clearly, I will show you in my Jupyter notebook. Here I created a new file. To use NumPy, first we need to import it. So import NumPy as np. I am creating an array with zeros function np dot zeros of. I am giving shape as 3. Now I'll print it. Here I got an array of size 3 and the data type of elements is float because it is the default data type. If you want to change it, you need to specify it in the parameters. Now Now I'll give the shape as 7. Again, I'll print it. Here I got an array with size 7 and the data type is float. Now I'll specify the data type 7 comma d type is equals to int. Now I'll print it. Here I got an array of size 7 and the data type is integer. In the same way, I can create an array with different size zeros of 2 comma 3. Now it will give an array with 2 rows and 3 columns. I'll print it. Yeah, here we got 2 rows and 3 columns. And again here I can specify the data type np dot zeros of 2 comma 3 comma d type is equals to int. Yeah, here I got 2 rows and 3 columns and the data type is int. This is about zeros function. Next one is full method. It creates a new array of given shape and data type but with a given fill value, not with zeros as seen before. Syntax is numpy dot full of shape fill value and data type. I'll show in my Jupyter notebook. First, I will import numpy as np. Now I'll create an array np dot full of and the size is 2 and the value I want to fill is 10.25. Now I'll print it. Here I got an array of size 2 and the value is 10.25. I'll show you another example. np dot full of size is 2 comma 5, that is 2 rows and 5 columns and the value is 10. I'll print. Yeah, here I got 2 rows with 5 columns and the value is 10. Now I'll change the data type np dot full of 2 comma 5 and the value I want to fill is 11.5 and the d type I want is int. Yeah, the value here I given is 11.5 but it only takes 11 because I specify the data type as int. This is about full function. Next one is random.rand function. It creates an array of specified shapes, but it fills with random values between 0 and 1. Here, the only parameter you need to give is the shape. I'll write the syntax numpy dot random dot rand of shape. This is the syntax. First, import numpy as np. I'll create an array. Array is equals to np dot random dot rand of. I'll give size as 7. I'll print the array. Yeah. Here I got an array of size 7 and the values are some random values between 0 and 1. I'll show another example. np dot random dot rand of 5 comma 7. Yeah. Here I got an array with 5 rows and 7 columns, and the values are some random values between 0 and 1. This is about random.rand function. Next one is once function. It creates a new array of given shape and data type but filled with ones. It is same as zeros function. Instead of zeros, we have ones in the array. Syntax is similar to zeros function. NumPy dot ones of shape and d type. Defaultly, the data type is float. I will show you in Jupyter Notebook. First, we need to import NumPy. Import NumPy as np. I'll create an array np dot ones of and the size I want to give is 8. I'll print it. Here I got an array of size 8 and the data type is float because the default data type is float. I'll show you another example. np dot ones of here I'll give size as 3 comma 5, 3 rows and 5 columns, and the data type is int. I'll print the array. Here I got an array of 3 rows and 5 columns, and the data type is int. I'll show another example. Ones of 2 comma 3. Here I did not specify any data type, so the data type is float. Let's check it. Yeah. Here I got an array with 2 rows and 3 columns, and the data type is float. This is about ones function. Next one is I function. It creates a 2D array with ones as the diagonal and zeros elsewhere. Syntax is numpy dot I of rows comma data type. It always creates a square matrix, so no need to specify columns, just rows is enough. I will show you in Jupyter. First import NumPy. Import NumPy as np. I'll create an array np dot I of and the rows I want to give is 2. Now I'll print it. Let's see the output. This is a square matrix. I mean, it is also a diagonal matrix. The diagonal elements are 1 and the remaining elements are 0. And the data type is float. I'll show another example. np dot I of 5 and the d type is int. I'll print it. This is a diagonal matrix of rows 5 and columns 5 and the data type is int. This is about I function. Next one is arrange function. It creates an array with evenly spaced elements as per the interval. Syntax is numpy dot arrange of start, stop, step and data type. Here start is the start value of the interval range and stop is the end value of the interval range. It is exclusive and step is the step size of the interval. Step can't be 0, otherwise you will get a 0 division error. I'll show you in Jupyter Notebook. First we need to import NumPy. Import NumPy as np. I'll create an array np dot a range of 4 comma 20 comma 3. Here 4 is the start value, 20 is the stop value, and 3 is the step size. I'll print the array. Here we got a new array of evenly spaced integers between 4 and 20, and the step size is 3. We will not include the last element. The last element is exclusive. I'll show you another example. np dot a range of 5 comma and the stop value is 100 and the step value is 10. I'll print the array. We got a new array between 5 and 100 and the step size is 10. What if I only give a single value? Let us check. Here I given only a single value instead of start, stop, and step. Here we got 0, 1, 2, 3, 4. If you give only a single value, it is considered as stop value, and the start value becomes 0 and the step count will be 1. Step count should not be 0, otherwise it gives a division by 0 error. What if I give only 2 parameters? Let us check. I'll give 5 and then 10. Guess the output. The output will be 5, 6, 7, 8, 9 because 5 is considered as the start value and 10 is considered as the stop value and the step count will be 1. Output is 5, 6, 7, 8, 9. This is about arrange function. This is widely used function in machine learning. Next one is line space function. It returns an array of evenly spaced values within the specified interval. It is similar to the arrange function, but it doesn't allow us to specify the step count in the syntax. Instead of that, it only returns evenly spaced separated values over a specified period. It implicitly calculates the step size. I'll write the syntax numpy dot line space start stop num and end point. Here start represents the starting value and stop represents the ending value. And here num is the amount of evenly spaced samples over the interval to be generated. The default value is 50 and endpoint can be true or false. If it is true, it indicates that the stopping value is included in the interval. If it is false, it indicates that the stopping value is excluded in the interval. I'll show you in Jupyter Notebook. First, we need to import NumPy. Import NumPy as np. I'll create an array np dot line space 10. 10 is the start value, 100 is the stop value, and 10 is the num. That is, I want 10 elements between 10 and 100. I'll print the array. We got 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Here 100 is also included because endpoint is set to true defaultly. For the same example, I'll change the endpoint to false and then we'll see the output. np dot line space 10, 100 and I want 10 elements and the endpoint is set to false. Now let's see the output. Sorry, I forgot to print array. I got 10, 19, 28, 37, 46, 55, 64, 73, 82, 91. Here 100 is not included and the elements are evenly spaced between the interval 10 and 100. This is about line space function. Next one is log space method. It creates an array with evenly spaced numbers on a logarithm scale. Its syntax is numpy dot log space start stop num endpoint and base. It is much similar to line space. Here start is the start value of the sequence, stop is the end value, and num is the number of samples we need to generate, and endpoint we already seen this before, and base is the base of log scale. We need to import NumPy. Import NumPy as np. I'll create an array np dot log space 10 is the start value, 20 is the stop value, and the number of samples I want to generate is 5. And I'll set the endpoint to true. I'll print the output. This is the output. The range of the output is between 10 and 20. 20 is also included because endpoint is set to true. Here I did not mention any base value, so the default base value is 10. I'll show you another example. np dot log space start value is 10, stop value is 20, and the number of samples is 5, and endpoint is true. Now I'll set base value as 2. Now we will see the output. This is the output with base 10, and this is the output with base 2. These are the various methods to create and initialize arrays in NumPy. Thank you for watching. See you in the next video. Bye bye.